This is page 300, number 11. Okay, so for number 11, we are graphing the function negative 3x over radical x squared plus 4. So let's get our pre-calc information down. We know that the domain will be all reals. We know that our intercepts will happen at the origin. If we test for symmetry, this function will be odd, so we need to make sure that what we draw has symmetry with respect to the origin. And then we need to find our asymptotes. So it looks like we don't have any vertical asymptotes, but we've got two horizontal at plus or minus 3. So now we can take our first derivative. So f prime will be the denominator times the derivative of the numerator minus the numerator. And then here's our derivative of the denominator all over the square of what's below. Now this will cancel here, and I'm going to factor out a negative 3 and an x squared plus 4 to the negative 1/2. And it looks like I missed an exponent here. This should be to the 1/2. Okay, so left inside we would have an x squared plus 4 to the first power minus, we took out our negative 3, we took out our x squared plus 4 to the negative 1/2, so we still have an x times an x, which is an x squared. Okay, next we'll simplify a little bit. We've got negative 3 here. In the brackets we'll be left just with 4 and an x squared plus 4 to the 3/2. So here is our second derivative. So our second derivative is actually never equal to 0 and also never undefined. This means that f has no critical numbers, which also means that f has no local extrema. But we'd still like to know where our function is increasing or decreasing, so we'll set up our sign chart. We're going from negative infinity to infinity. Negative 12 is always negative, x squared plus 4 is always positive, so our derivative is always negative, which means that f is decreasing from negative infinity to infinity because f prime is negative. So no local extrema, but our function is always decreasing. Now for the second derivative, I'm just going to rewrite my first derivative. That's negative 12 times x squared plus 4 to the negative 3/2. Okay, our second derivative is going to be positive 18 which leaves us with 36x over x squared plus 4 to the 5/2. Now the second derivative is equal to 0 when x is equal to 0, but the second derivative is never undefined. So we have a possible point of inflection when x is equal to 0. So we'll set up our sign chart, 36x second derivative, and we're going from negative infinity to 0 to infinity. So negative positive, positive positive, negative positive. So we do have a point of inflection. We can say f is concave down and then f is concave up. and f has a point at x equals 0. Okay, now we can begin our graph. And we've got an intercept at the origin. We know that our horizontal asymptotes are at 3 and -3. And what else do we know? Our function is always decreasing, but we go from concave down to concave up at x equals 0. So always decreasing, so decreasing concave down, decreasing concave up. And there is our graph of f.